Hi everybody, welcome to another video in course Algebra, section 1.5 quadratic equation. Before we go to quadratic equation, just review complex numbers. So before we, on previous section we have square root of -2 and I said that is imaginary, so that is not real numbers. So imaginary is something that is not real, and then we have complex. So first, what we define imaginary unit, it is I, and I is equal to square root of -1. Now if we square both sides, I square both sides become I square square root of -1 square, and that gives us -1. So I square is equal to -1. More precisely, I equal to square root of -1. The set of all numbers in the form of a plus bi, where a is real numbers, b is real number, together a plus bi is called the set of complex number. So the complex number we have all the real part along with all the imaginary part. So a is real, b is imaginary part. Notice that b is real but bi is imaginary. So we have a real and we have an imaginary. And the numbers a minus bi is called the complex conjugate of the a plus bi. So what we have is one of them having the negative, one of them have the positive. When we multiply them out is just like a foil, first with the first outer and then inner and then last. Take the first one, multiply with everything on the second, and then take the second, multiply with everything on the second in the second parentheses. Right, so a times a square, a minus bi. So we treat I as a variable. Worry about these values later. So do that, multiply them out. That's what we have. And now combine like terms, minus abi plus abi. So this cancel out. And I square is equal to -1. So with that we have a square minus -1 for I square, and then b square minus -1 minus that's a plus. Alright. But most importantly, we need to know how to find the square root of a negative number. So what we do is, if we see the negative inside the square root, we will take it outside as imaginary number. So what we do here, we see there's a negative inside the square root. So first thing we take it out, and that become the imaginary unit. What's left is just square root of 4. Square root of 4 is 2. So we have I times 2. So we say that equal to 2i. So always take care of the negative inside the square root first, and that is the imaginary unit, and then worry about what's left later. Of course we can leave it like this, but we can do the prime factoring of 12. 2 times 6, 2 times 3. So 12 is, we have 2 of the 2, and then 3, right? 2 of the 2 and then a 3. After that, square root 12 is equal to square root of 2 square equals square root of 3. Square root of 2 square is square root of 4, which is 2. So square root of 12 is equal to this is square root of 4, which is 2 square root of 3. So we end up with I 2 square root of 3. But usually we write in alphabetical order, numbers first, letter. So we put a I 2 I square root of 3. Usually we put in that order. Right, like I said, we only need to know that part, so that helps us with the calculation later. Alright, now back to quadratic equation. Quadratic equation is just equation where we have a second degree polynomial. So we have the highest term is going to be x squared, and then we have an x and a c. Also simple enough. And in this section we learn different ways to solve quadratic equation. In particular, there will be 3 different methods. The first one is factoring. So factoring, in order to do solve equation by factoring, we have the zero product principle. Right, it has to be 0. When 2 things times together equal to 0, one of them has to be 0. This does not work with any other number. For example, if we say a times b is equal to, let's say, 8, we cannot say one of them is equal to 8 because one of them can be 2 times 4, right? So if this is any other number, this will not work. That's why it has to be a 0 product principle. So they have to have 0 there. And also have to be a product. It cannot be a sum. It doesn't work. So 2 things times together equal to 0. One of them has to be 0. If you think about that way, it makes sense, right? If the product is 0, one of them has to be 0. So the problem is, how do we turn that into a product? And that process is called factoring. So we turn a polynomial into factors. Right. How do we do factors? How do factoring? Right. I'm sure you've seen that somewhere already. And this is the way I'll do it. So first, solving by factoring, I move all the numbers to one side. So I subtract 4 on both sides. So we have 2x squared plus 7x minus 4 equal to 0. Right. By the way, as I mentioned on the first video, you don't have to bring out the note, but you just need to, if you want to take note without bringing out this, you can just write all the example, will be fine, because I spend most of the time on the video working the examples. Right. Now, factoring. Somehow we turn this into factors. That would be nice. But this is the way I do factoring. I'm just going to write the step. So we have 2, 7, and negative 4. So the way I do factoring is using the product and the sum. So I will have 2 numbers multiplied together equal to the first number times the last number. First coefficient, last coefficient. When they add together, it will equal to the middle number. I have to find that combination of those 2 numbers. And what do we do with those 2 numbers? Well, we'll see. Right, so in this particular case, what we do is we're going to find 2 numbers multiplied together equal to the first times the last. The first is 2, the last number is negative 4, so that is negative 8. But they have to add up together equal to the middle number 7. So let's try. Let's list the possible case. To get to negative 8, we might have 1 times negative 8 or negative 1 times 8. Of course, it can be 2 times 4. I mean, 2 times negative 4 and negative 4 times 2. Just think about the natural numbers, or I mean, think about integers here. Now, we just look when we add up to 7, and we see that these 2 numbers add up to 7, right? So that is the right number we have. So we find 2 numbers satisfy this condition. So satisfy 2 numbers. So that is how I do the factoring. So we do that and we find negative 1 and 8. Once we find negative 1 and 8, that is where we split the middle term. We split that in half. One is negative 1, the other one is 8. Doesn't matter the order, negative 1 and 8 or 8, negative 1. Right. Let's write the rest of the problem. They have an x here, so negative 1x plus ax minus 4. So after finding the two numbers, split the middle term using those two numbers. And then if we group the first two and then the last two. The first two, both of them have x in common, so I factor out x, left with negative 2x minus 1. And then ax minus 4, they have 4 in common, positive 4 in common. Factor out 4, we have 2x minus 1. Now, if everything works out perfectly, we should have the common factor of 2. In this case, common factor is 2x minus 1. When we write out the common factor, we left with x plus 4. So we just have x plus 4 equal to 0. Now we can apply the zero product principle. We have a product equal to 0, so one of them has to be 0. So we say 2x minus 1 equal to 0, or x plus 4 equal to 0. And the rest is simple. Subtract negative 4 on both sides. We have x equal to negative 4. Right here, plus 1 on both sides. We have 2x equal to 1. And divide by 2 on both sides, we have x equal to 1/2. Yeah, divide by 2 on both sides, x equal to 1/2. So the solution is x equal to 1/2 or x equal to 4. If we're going to write that in the set, once again, the set is everything in the curly bracket. In this case, the set have two numbers, 1/2 and negative 4. Right, that's simple enough. So that's how we do the factoring, and using factoring to solve quadratic equation. Right, next, I have x squared minus 7 plus 10. The same way we do factoring, right? So we find two numbers, multiply together. Go to first, which is 1, times the last, which is 10. So the product is going to be 10. First times the last. Add up have to be equal to the middle number, negative 7. So now we list all the possible for that to get to 10. We might have 1 times 10. They don't add up to negative 7, so keep going. Negative 1, negative 10. Again, don't add up to negative 7. 2 times 5, that also 10, but don't add up to negative 7. But negative 2 and negative 5. Negative 2 and negative 5 add up to the middle numbers. So this is the right combination. Negative 2 and negative 5. So we split the middle term using the negative 2 and the negative 5. Of course, the middle term have x to it. And then we just have x squared. Right. Now, next part is group the first two terms and the last two terms. The reason we split the first two terms, so original quadratic equation have 3 terms. So we have to split the middle term, so we have the first two and the last two. Factor out x, we have x minus 2. And negative 5 and 10, look like we can factor out negative 5. And we have x minus 2. If everything works out perfectly, we should have the common factor of x minus 2. So I factor out the common factor of x minus 2. We left with x and a minus 5. Once again, we have a product equal to 0. So one of them is equal to 0. And then add 2 on both sides, and then add 5 on both sides. We have x equal to 2. x equal to 5. So once again, if we want the set, we set the set up to and 5. Right, simple enough. Right. Now we have this problem, x squared plus 3x minus 5. So once again, I'll try to do factoring. So two numbers times together equal to first times the last, and then they add up together have to be equal to the middle. Now we will guess the product of 1 to get to negative 5 when be 1 times negative 5 or negative 1 times 5, and that's all the all natural numbers, I mean all the integer solution to this. Of course, to get to negative 5 we might have negative 10 times 1/2, but now we only use natural numbers, I mean only use integers here. So because there's no way we can use those and add up to 3, so in this problem we just say we cannot factor using integers. Cannot be factored using integers or rational numbers. Yeah, because none of the integers combination give us satisfy these two conditions. So in that case we just say we cannot be factored using integers. So in that case we have to use different method. So rational number, when it work out, it's easy and look elegant too, but it's not always work. Something we end up with something like this. So there have to be a different way that works all the time, and one of them is using the completing square here. So completing square, before we study that, we have the square root properties. Square root property says that if u is an algebraic expression and d is greater than or equal to 0, then u square is equal to d, implies u equals square root of d or u equal negative square root of d. Right. Probably easier to think of this as an example. Let's say we have the equation x squared equal to 9. What we do is we can take the square root on both sides. Square root of 9 is 3, but we know that the answer is not just 3, right? We know 3 squared is equal to 9. That certainly works, but at the same time negative 3 square is also equal to 9. So we have a square equal to something, the answer could be positive and negative. So there will be two of them, one positive and one negative. Later on we can just do like this. Let's say to have u square equal to d. What we do is we're going to take the square root on both sides, but every time we take the square root on both sides it will be plus or minus. We will study about this a little more in the next section. That gives us u equal to plus or minus square root of d. Right? And we're going to use these properties later, but now we have to focus on the completion square. So what is completion square? Right. So let's say we have the square and multiply them out. Let's say what do we have? A plus b square is a plus b times a plus b. Once again, just FOIL. First times everything in the second. A times 8 a square, a times b, b times a, but let's just write a b, and then b times b, b square, right? So a square, combine like terms, so ignore the a. Actually I should use x here. What we see is that in the middle here we have 2 and b. Actually, I said I should write x instead. Let's do x plus 8, right? So multiply them out. Same thing, we have 2ax plus b. Now this is a quadratic polynomial, so there's no b, just a square, sorry. What we see here, of course, if we multiply them out, that's what we have, just like what we have here. Notice that the middle here, what we have, the relation is that we're going to take half of 2a, which is a, and then we're going to square it. So if we want a complete square, if we want the square, take the middle term, cut it in half, and then square. So add a number to complete a square. So I do the same thing, cut this in half, which is 4. So I say half. And then we square it. 4 squares is going to be 16. So we're just going to add 16 into it to make a perfect square. Right? Let's say that's going to be x squared plus ax plus 16. So now we determine that number. Now, in terms of the relation, this is going to be equal to that square, right? Notice that in that square, what we see is x squared, the first term, take the square root. So I'm going to take the square root of that, square root of the last one, and the plus in the middle. So in order to find the third term, is half of the middle term square, and after that we have square root first, square root last, and that's pretty much it. Right, same thing. For this problem, cut this in half, and then we square both sides and square it. So I'm just going to say to negative 3/2 square. So we have x squared minus 7x plus negative 7/2 square. Of course, negative 7/2 square is negative 7/2 times negative 7/2. Negative 7 times negative 7 is 49/4. We don't even need to know that. So even when we write like this, we don't even need to do just square root. We just take this x squared, so that's going to have an x here, and the sign is a plus. Just like this, we have the 4 here, right? All we do is just have the x, and then that sign, x plus 4. Same thing here, we have a negative 7/2. Just going to put an x in front of it and make a square. Yeah, so that is equal to this. Once again, just put an x to it. If it's positive, put a plus. If it's negative, just keep it negative, and then make it a square. So that's how we do the complete square. Now, how do we use that to solve our problem? So let's look at this example. Solve the equation by completing square. So with that. So first thing we do, completing square is different than the zero product principle. Zero product principle, we want 0 on the right hand side. Let's just go back and note that on page number 3. For this zero product principle, what we need is 0 on the right hand side. So we're going to need 0 on the right hand side, on the right side, which is on the right side. So that's why we get 0 on that side. Completing square is different things. We just move that term, actually that number, to the other side. That's right. So why we do that, see in a minute. What we do next, we're going to add something on both sides. Just say it. we're going to need to add something on both sides. To do that, to complete a square, right? I will continue writing over here. Right, how do we determine the number that we add on both sides? Well, that is just like what we did earlier. Half of the middle term squared. So we take half of 4, which is a plus 2, right? And then we squared 2 squared is 4, so I'm going to add 4 on both sides. Right. And then if it is x squared, it's easy. I'm just going to put an x here. Then 5 plus 4 is negative 1. Alright. So we have that. Next is we use the square root property. U square equal to d, u equal to plus or minus square root of d. What I do is I will take the square root on both sides. Take the square root on both sides, and the most important rule here is when we do that, there's a plus or minus. Square will cancel the square root here, but there will be a plus or minus on the other side. And square root of negative 1, remember the first thing we learned in this section, square root of negative 1 is I, so that's just I. And then finally, to get x by itself, just subtract 2. So we have x equal to negative 2 plus or minus I, which in turn, if we're going to write out, it could be negative 2 plus I or negative 2 minus I, or we write as a set. Right, so that's simple enough. Yeah, if the number is simple, a number could be complicated like this. Right, once again, complete square, we're going to need only 2 terms on the left hand side, because it is easier to determine the term we add to it. So we need to add something on both sides. On the right hand side, we still have negative 10. Right? So we will have half of the middle numbers. With the negative. And then we're going to square that. And add it to both sides. Right? In here, we're just going to put x and make it a square. Alright. If we have a calculator, just go ahead and use it. We have negative 10 plus negative 7 halves square 2.25. So what is square root of 2.25? Yeah, that could come later, but for now, if you have 2.25 and we want to have fraction, hit math, convert to fraction, 9 over 4. Yeah, so negative 10. If we do by hand, negative 10 plus negative 7 over 2 square, negative 7 over 2 square, we already did that. Multiply square across 49, multiply square across 49 over 4. So negative 10 plus 49 over 4. Now, common denominator, negative 10 is negative 40 over 4 and 49 over 4. Now both of them have the common denominator of 4. Combine the top, negative 40 plus 49 divided by 4. So that gives us 9 over 4. Of course, that's what we have. Right, next we will take the square root on both sides. when we take the square root, keep in mind there will be a plus or minus on one side. Now square root cancel out, we have x minus 7/2. That will be plus or minus. We can split the square root on the top, square root of the bottom. We have 3/2. Right, square of 9 is 3, square of 4 is 2. And finally, we can add 7/2 on both sides. So if x equal to 7/2 plus or minus 3/2. Right. So we might have the plus case. 7 combine the top, we have 10 over 2, which is 5. And subtract 7 minus 3 is 4 over 2, which is 2. I think we did this problem before. And that equation, we have x equal to 2 and x equal to 5, which is exactly what we have here. Alright, so that certainly works. Right, but the easiest way is using quadratic formula, because that is the quadratic formula. And then at least I have to show you where it's not coming from. So the point here is where it's not coming from is just pretty much completion square. So completion square, so we minus c on both sides. Of course, I could just say that is a formula, use it, but I just want to prove. Right. The method here we choose half of the middle term and the square. And so, but that only works if the leading coefficient is 1. So in order to get to 1, I have to divide by 8 on both sides. So if x squared plus b over a x c over a. Right. What we do next is half of the middle term square, half of that square, and add it to both sides. So we have b over a divided by 2. So b over a divided by 2 or over 1 multiply reciprocal. So that's just b over 2a. And that half of the middle term. And then we're going to add on both sides. But the right hand side is going to be a square like that. So we have negative c over a. And we have to square it and add to both sides. So add on both sides. We're going to have b over 2a squared. Yeah. So square it and add to both sides. But the right hand side is going to be a perfect square like that. So we have x plus b over 2a squared equal to negative c over a. This one square is b squared over 4a squared. And then common denominator, x plus b over 2a squared. The top, that would be minus 4ac plus b squared. And finally, take square root on both sides, put a plus or minus. We have x plus b over 2a equal to plus or minus b squared minus 4ac. Square root of 4a squared is 2a. Bottom line is when we move that to the other side, we have the quadratic formula. So in a sense, actually quadratic formula comes from completion square of the general case. Right. Once we show that, when we prove that, really don't need to memorize that. Just use the formula. Right, the b squared minus 4ac, that is called the discriminant. If it's going to be positive, we have two real solutions. If it's 0, we have one repeated solution. If it's negative, we have two imaginary solutions. Right. So we start with this. Just quadratic formula: x equal to negative b plus or minus square root of b squared minus 4ac over 2a. So in this particular case, a is equal to 1, b is negative 7, and c is equal to 10. So negative b is negative 7, plus or minus b squared minus 4ac, b squared minus 4ac over 2 times a. So negative 7, so that's 7, plus or minus negative 7 squared, 7 times 7 is 49, over 2. So pretty much we have 7 plus or minus square root of 9 over 2. Square root of 9 is 3, so we have 7 plus or minus 3 divided by 2. Now we have the plus case, 10 divided by 2, which is 5, and the subtract case, right? Yeah, so straightforward. Of course, we use completeness square. We have 5 and 2. Of course, you see the numbers look familiar. We have 7 half plus 3 half, 7 half minus 3 half. So of course, quadratic formula derived from completeness square. So that's why the numbers look similar to that. Right. Next, we do this problem. X equal to quadratic formula negative b plus or minus b squared minus 4ac over 2a. Right, in this particular example, a is 1, b is 3, and c is negative 5. Negative b, negative 3, plus or minus b squared minus 4, a is 1, c is negative 5, over 2 is a. So we have negative 3 plus or minus square root. 3 squared is 9, minus that plus 4 times 5, 20 over 2. So in this case we have negative 3 plus or minus square root of 29 over 2. 29 is a prime number, so that is the answer we have. Of course, we can write as the set notation. Here's one of them, and here's the other. So very straightforward, right? Actually, it works with imaginary number, imaginary solution, complex solution as well. So we'll do one more example using quadratic formula. Like this example. Simple enough. X equal to negative b plus or minus b b squared minus 4ac over 2a. A is 1, b is 4, so negative 4 plus or minus b squared minus 4 a c over 2a. So that gives us negative 4 plus or minus, we have 4 squared 16 minus 20 over 2. So minus 4 plus minus square root of that negative 4. 16 minus 20 is negative 4 over 2. Now, we did say that negative inside square root is the imaginary I. So we have negative 4 plus or minus square root 4 is 2i over 2. What's next is the most common mistake I see is you cancel the 2 here or cancel the 4 with the 2. We cannot do that. We can only cancel when there's a product or a quotient, multiply or divide, we can cancel. So here what we can do is that both of them divide by 2, so we actually, what we do is factor out the 2. Factor out the 2, we have negative 2 plus or minus I. And we can only cancel when it is the product, when it's multiplied. So that is negative 2 plus or minus I. Because that's what we have. It's the solution for this problem using completion square. Right, our bottom line is there are 3 ways to solve quadratic equation. Factoring look elegant, but factoring sometimes does not work. Quadratic formula always work, and we don't have to think about complete square. Complete square is a little more complicated, but we can use completion square to derive the quadratic formula. But that's all I want to cover in this section 1.5. Thank you for watching. See you in another video in Algebra.